Welcome again to Coding Between the Lines. This is your C++ Sherpa, Jason Monroe. What we're going to be doing this week is looking at Chapter 8. And there's two major topics covered in Chapter 8 that we're going to implement in our FilesIO project that we did 2 weeks ago. And those two major topics are strings, or the string class, and actually that can be broken into two parts: C strings as well as regular strings. We'll talk about those just a little bit, and then also vectors. And what vectors do is they fill in for the shortcomings of arrays. With arrays, if you need to add elements to the array, you should have noticed from chapter 7 on arrays that if you try to place an element into an array that outside the bounds of that array, it's going to be a destructive action, and whatever's sitting in memory consecutively after all of those arrays will get overwritten. So there's an issue with arrays adding to them or maybe even shrinking them. What vectors do is they allow you to add elements to the vector and then also remove elements from the vector at any point, at any spot. So they're really a useful tool, and I use them more often than I do arrays for that very reason. Now, they're not as efficient as arrays because they are handling that storage shortcoming that arrays have. So they're not as efficient, but they are a lot easier to use within your program. And one other thing we're going to do with this project, I'm adding an element here that actually isn't covered in your text, and I'm not sure why the text chose to the topic of creating your own header files. Up until this point, we've included those header files that already exist, the ones that are predefined. But as a programmer, you can create your own header files and thus separate your code into separate files, separate portable files, just like we use the IOStream class, or I'm sorry, the IOStream header file in all of our projects. You can create your own header files that you can include in other projects of yours, and then by doing so, we can separate layers of a program and create these portable files that can be included in other projects. So first thing we need to do is open up the files input-output program that we created 2 weeks ago. And here you see mine. Let's just refresh our memory as to what's in this project. So header files that we've included are the IOStream class and then the FStream class. Remember, that was needed for the file input and output objects. And we have two functions, add names and view names. And we've got this menu-driven program where we ask the user if they want to add names to a file or view names in the file and exit. And then we have those functions here that will add names to a hard-coded file name, and we just called it names.txt, and then also view the names in the file. So what I want to do with this project this week, what we're about to do right now, is we are going to add a third function to sort the names in our file. It would be nice to sort them alphabetically. We're going to do that, and then we're going to allow the user to type in a full name, so a first and last name with a space in it. So that's going to require the use of a function that we're picking up from Chapter 8. Hopefully you've done the reading and looked at the PowerPoint notes. It's the getLine function. So we're going to implement that, and I'll talk about that when we get there. And then what I want to do is I want to separate out of this add names and view names function. I want to separate the part that actually communicates with the file, and I want the user to be able to type in a file name. That will make our program a lot more dynamic. Then you can create files with whatever name you want, and you can create multiple files with this same program, and then you can view multiple files with this same program just by typing in the file name. So we're going to allow the user to do that. And so I want to create a separate file, a separate header file, a user-defined header file that we will include up here that will be our database accessor. Or these are just text files, but we're considering them our database for this project. So we are going to put all of that logic. We're going to put that into a separate header file, and that header file is something that we can include, like I said earlier, in other projects. We're going to have it be generic and autonomous so that we can just send information to it and say, okay, connect to this file and send me back the data. And that's where vectors are going to step in. You can have a function with a return type of a vector. And that's one other thing that vectors do that arrays cannot do. You cannot have a return type of an array. Alright, so where I want to start then is I want to start with moving or migrating this information, this logic that connects to the external file. I want to migrate that into a separate header file, and so we want this additional header file to be portable and like I said before, autonomous. It needs to be standalone so that it's something that we could add to other projects if we wanted to. Okay, so what we're going to do is we're going to start by adding a second file to this project. And one thing you need to be aware of in order to do this, you can't just have the CPP file open. Notice how over here in my project tab there's nothing there. That's because I just double clicked on the CPP file and opened up that CPP file. Now yes, I can compile this CPP file as it's sitting there, but you need the whole entire project open within dev, within this dev compiler, so that you can add files to it and they will all be connected. So what you need to make sure you do, I'm going to close that, and when you open your project, it's this .dev file, and some of you made the mistake of actually sending me the .dev file in your homework examples. The CPP file contains the code, but this dev file is the project file that just kind of links everything together. That way the IDE knows where to find files and it associates all of them with one another. So that's the file you need to open, and when you open that file, you'll notice over here at the left now we've got this project tree, and we see our main CPP file there. So if you right click over here on the left on the top level here of the project, you can add a new file, and it's untitled to begin with, and let's go ahead and do a save as for this file. It's currently just called untitled CPP, and the button I clicked there, by the way, is File Save As. And so down here I'm going to call it, this is going to be our database accessor, so I'm going to call it data accessor. And down here, instead of saving it as a CPP file, this isn't a CPP file, it's going to be a header file. So go down here and choose the header file, and it'll put a .h at the end, and then go ahead and hit save. Okay, so now we've got this data accessor.h file in addition to this .cpp file. Now, although you don't see that at the end here, these include statements that we've been using, the IO stream and the F stream, those are header files. And what a header file is just additional C++ code that may or may not contain an int main in it. Typically, your CP you can have multiple CPP files, but there should only be one file that has an int main inside of a project. That way the C++ compiler knows where to initiate the program. Okay, so I've created this data accessor file, and I'm going to go ahead and add some comments up here at the top. By the way, this if you're looking in your textbook for this creating a user-defined data accessors, this is that one thing, supplemental thing that's not in your text that I feel is important enough to share and to use with you, or to show to you. In formal programming in the field, it's a very common thing to separate your classes. Once we get to object-oriented programming, separate your classes into their own header files. So this is an important topic, I felt, and you will not, like I said, find this in your text anywhere, but it's a really simple concept, just moving everything into their own file, and that file you can insert or add to other projects as needed. Okay, so I'm going to just give this file a little blurb here, up here at the top. I will say this header file contains two functions. I'll call them get data and save data, which access a file, and we'll say access a file and retrieve the contents, or place additional text into the file, respectively. Okay, just a simple little blurb up there. Okay, now a header file, since we're going to be including it up here, when you have a file that's included up here, your compiler will compile it first before it gets to the rest of your code. That being the case, your header file may need to have its own include statements, and putting include statements in it will allow this header file to be more portable. So I'm going to include IO stream, and I'm going to include the fstream class. That way we can access our files with the input and output file stream. That'll be good for now. I'm going to add a few here later as we go along. Also going to put the using namespace standard in here. Now the good thing about a header file, we are just defining functions in the header file. So we don't have to have the declaration of the function. The function is defined in the header file before it is used. We'll be using it in the main, but since we're going to include this header file right here, it will be compiled, and so the definitions will be viewed by the compiler before they are actually accessed. So we don't have to have the declaration, we can just go right to defining our function. So I'm going to create a function called save data. And I'm going to add some formal parameters here as we start to flesh out this function. So what I want this function to do then is I want it to be the function that accesses the text file and puts the information into it, or dumps the information into it. So I'm going to migrate that out of this add names function inside my main CPP. So if you have both tabs open here, we can take a look at it, and let's do the planning here, and then we'll go ahead and migrate, and we can cut and paste the code. So here in the add names function, what I want it to do is I just want it to prompt the user for the name. We'll just start prompting the user for the name of the that they want to put into the text file, and we will place those names. What we're going to do is we're going to package them into a vector, and then we're going to ship that vector off to this save data function. We're going to just send it the entire vector and have the save function cycle through the vector and take all of the names and dump them into the text file. Okay, and then also after we're done doing that, I want the user to be able to type in the name of the file. So, but we got to do one thing at a time. So we'll leave this alone for now. The hard-coded file name, we'll leave that alone, and then we'll change that up so that we can allow the user to type in a name. Okay, so first thing I'm going to do is this object instance. I'm going to cut it out of my add names, and I'm going to paste it right up here in my save data. I just use Control V and Control C. Just a little tip. I used to rely on the right click for copy and paste, but what I've found to be a lot quicker if you're going to be doing a lot of programming, if you put your pinky on the control button, and then you can use your index finger to hit the X button, control X cuts, or if you're copying, Control C, and then with your pinky still on that control button, you can rotate over and click on the Control V, and that's what I do. And you can be operating the mouse with your right hand while you do that with your left hand. Just a little trick that I use. It makes copying and pasting a lot quicker. Okay, so we want to migrate the pieces. That's what I'm doing right now. I'm migrating the pieces of this add names function that are dealing with the actual file and putting them into this save data function. Okay, so opening the file, that's something I want to migrate out as well. I'm going to copy that, or cut it, I'm sorry, Control X, data accessor, Control V. And like I said, we're going to leave this alone for now. When you're programming and you're making large overhauls to your projects, you're trying to expand on them, tackle one thing at a time. You may have a laundry list of things you want to do to it. Tackle one thing at a time. When you make that one change, then you run your project, make sure that's working. That way you don't have a bunch of errors compiling, and I mean compiling or adding up, not compiling as in, well, I guess that would be true too. They would be compiling all at the same time, so you'd have this big list of errors. Anyway, you want to code a little, test a lot, especially when we're making these large changes to the structure of our projects. Okay, so I wanted to migrate that out. This file out stuff, this while loop, it's while string name is not equal to Q. It's dumping the data into the file. We will need a loop in this string add names, but it's going to be a little bit different than this current loop here. So what I'm going to do is just for now, I'm going to cut this out where we're actually putting data into the file. I'm cutting that line out, and I'm going to paste that in here. The idea here is that the add names function is going to create a data structure that is containing all of the names that we're wanting to put into the file, and we're going to ship that whole thing off packaged inside of a vector. So right now I'm just thinking about removing everything from this add names function that deals with the actual connecting to the file. So this close file, we need that out of there as well. Let's cut that out and paste that down in here. And the way I'm going to approach this, I'm going to first overhaul this add names function and make the changes to it. That will do what I just mentioned, put all the names into a vector. And then I will call this save data function and send to it, and I'll add these formal parameters here in a minute. I'm going to send to it all the stuff that I want, or the vector. I'll send it the vector, as well as we're going to eventually add the file name, allow the user to add the file name. And then we will finish this save data function operating with those parameters. We'll finish this and have it cycle through the vector that it's going to receive. So I can't really finish this save data function until I have completed the add names function, which is going to be calling it. Okay, so looking at this add names function, let's add the first thing that we'll need in order to package all of the names into a single object, and that's going to be our vector. So here's our first new topic from chapter 8, the vector class, V-E-C-T-O-R. And the way you create a vector is you write the word vector, and then with the angle brackets open and close, it looks kind of like we're including a file like up here, but it's a little bit different. What this is doing is this is creating a vector where all of the elements in the vector are of type string. So this is just the symbol, same symbol, but it's used for a different thing. That's what makes C++ probably more difficult or a little more confusing than some of the other languages, is C++ will reuse the same symbols only for different things, whereas your modern languages like Java and C# don't do that. They try to avoid that. For that very reason, it's easy to get confused. Oh, well, that symbol means something different used in this context. So here what we're doing is this is just defining what the element types are of this vector. So think of a vector like an array, only there's a bunch of code already written for you in this vector class that we need to include that will allow you to add elements and remove elements on the fly and change the size of this vector. So there's a bunch of code already written for you. It's a pre-written class, and this is distinguishing it between and then the word vector between an array of a certain type. That this is the syntax that C++ writers chose in order to determine what the or declare or define whatever you want to say, what the data or the type is, what the each element type is. Okay, so then we give it an identifier. I'm just going to call it new names. And then after the identifier, you put in parentheses the size. And if you want to just start with the size of 1, what a vector does is as you add elements to it, it will double the size of the vector as you add elements. So if you start with 1, then add another element, it will double it to 2. And then if you add another, once you get to fill it up to 4, it will double it to 8. So that is just starting small, and the vector can grow as necessary. And that, anyway, you don't even need to really know that. That's what the vector is doing in the background when you add elements to the vector. But if you just start at 1, then that gives it a starting grounds, and it won't be any larger than you really need. Okay, in order to use this vector, we need to include the vector class. Okay, so it's just include vector. Alright, and so like I mentioned before, what I want this function to do is I want it to receive the name from the user and then stick them in the vector, and then when it's all done, or when the user's all done, then we will ship that off to that save data function. Okay, so I've got this vector, and then I ask the user to enter a name. And so then for my storage loop, I can still use the Q to quit. But now what we're going to do inside here, remember here I had that file out originally. What I'm going to do in here is I'm just going to add the element or the string to this new names vector. So it's new names dot, okay, and notice how when you start using functions inside that vector class, what you see popping up here are the function names. If I just type P, you'll see the options, and it's this pushback that I want. The enter function, you can use your arrow keys if you would like and hit enter to select the name here, and it kind of does an okay job there. What they're attempting to be like is the IntelliSense, if those of you who've used Visual Studio and programmed in a Microsoft language. So anyway, it's new names pushback, and then inside the parameters here, you just pass to it that string name. Okay, and then we're reprompting the user, tell them enter another name or Q to quit, read it in, and then while that's not Q, then continue. All right. And then when that function is done, or not function, I'm sorry, the while loop, once that while loop is done executing, the user has typed Q, they're done typing names in, then we just want to send that information to the save data function. So send vector to that save data function. So I'm going to call save data, pass to it new names. Okay. Alright, so now let's go to the save data function, and let's add this formal parameter, allow it to receive a vector, and then we'll update the save data function or flesh it out so that it will cycle through that vector. So clicking over to my data accessor header file, down here we still have that hard-coded file name in there. Up here at the top, that's where we need to have it receive the vector. So I'm going to type in vector and then string. And it is not a bad idea, common naming convention, if you want to put V in front of the name of your identifier of a vector. I could have done that here in my add names, make that like V new names or something like that. I'm going to do it here since this function is going to be, or this header file is supposed to be something that's portable. I'm going to just call it vdata. And the reason I'm giving it this ambiguous name data, again, this save data function, the idea is this header file, I'm going to create it in a general sense so that if I wanted to, I could take this header file and attach it to another project. And actually, I'm going to ask you to do that in the future. So, if you give it a generic name, then you'll know, okay, this thing is receiving data of some type. It doesn't necessarily have to be a list of names, but it is string data. Okay, so it's receiving that vector now, and we can do something with that vector. So with vectors, this is the great thing about a vector. They have inherent a function that can determine what the size of the vector is. So what you maybe remembered from for loops, how for loops lend themselves nicely to arrays and also vectors, especially because if we know the size while we're programming, or that we can tell the program where to find the size of the vector, then we can loop through it with a for loop. Okay, so I'm going to comment here and just say dump vector into file and for int, and I'm going to use n equals 0, n less than, I'm going to do vdata dot size. So this size function can retrieve the size of the vector. Okay, now the vector class, this size function is in the vector class, so we actually need to include that here. Yes, we did include the vector class over here in our main CPP file up here at the top, but remember we're gonna be including our header file up here, and so it might get compiled before the rest of this main function gets compiled. So adding it here also makes this data header makes this data accessor header file portable. It's already got the include statement that it needs in order to compile what's in there. So vector class here, we're using the vector. We need that. Okay, so in my for loop, what I'm going to do is I'm going to just have that file out statement right here, this output name to file. Put it right there. And instead of the output string name, it's the vector. And so how do you access an element in the vector? You use the .at function, and I'm going to pass to it in. Okay, so file out, outputting to the file vdata .at in. Okay. Okay, and then we've got our file out close. And I'm just going to put a little comment here, end of that save data function. For young programmers, it's a really good idea to put comments in the closing braces. That way you can keep track of these. Now the Dev IDE actually does a better job of helping you keep track of your braces than some other compilers I've seen, Visual Studio included. With this Dev IDE, you can just click on one of the two braces and it highlights the other one, and it also has that little highlighted line in there. But as best as you can, keep these lined up and know what they're doing. Okay, so now I have an autonomous function here. It receives a string vector, and then it outputs to this specific file, which we're going to change that here in a second. Outputs all that information into a file, closes the file. And we're in append mode. If you wanted to, you could have the user decide whether they wanted to append or not, and have that be maybe a Boolean parameter. But for now, we're just going to assume that they want append mode. Okay. Looking back at my add names function, I believe we've got something here that we can now test and see if it's working. The only thing we need to do is we need to include that header file that we created. So I'm going to include, and when you include a user-defined header file, instead of using the angled brackets, you use quotes. So data accessor.h, and there you actually have to type the .h at the end. Okay, so I'm going to compile this. Alright, no errors, that's good news. So I'm going to go ahead and run number one here, add names to a file, and I'll add a new name to my text file. And I'm just going to try one name and quit here. Now we can't view the names in that file yet. Well, actually, yeah, I guess we can. Okay, so there are the names in the file. So it added George to the list of names. Alright, that's mighty fine. So our add names function is now creating a vector and packaging that vector, sending it off to the save data. And great thing about a vector, we don't have to know the size. We can just ask the user for names. We can add them dynamically to that vector and package the vector and send it off to this save names. All right, or save data function. So now the next step here, let's create a get data function and migrate all of the stuff out of view names out of there. That way we have in our data accessor, we also have a getter, a function that will get the information from that text file. Okay, so in my data accessor, I'm going to create void get data, and remember what I mentioned earlier. The great thing about a vector is it can be used as a return type of a function. So actually, instead of a void return type here, I'm going to use a vector return type, vector string, and then I'm going to call it get data. Now it might be a C++ convention to use lowercase names for your function names. I program in several different languages, so sometimes I remember to do that, sometimes I don't. So here with this header file, I'm capitalizing the names. The most important thing is to be consistent within what you do, and then also if you're programming in a team, or that your whole team is consistent. And this get data function here, I'm going to, just like I did with the save data function, I'm going to migrate into it all the stuff from this view names that deals with files. Starting with the input file stream, I'll cut that out of there, paste it here. Okay. So that opens the input file stream, and then here where we're opening the file, same thing. Let's cut that out of there, paste it here, and back to the view names. Here where we're putting the information into the file, let's cut that out of there. Or actually here we're, well, both of these lines really. So actually let me grab that, put it in here. Now this while loop that's looping through till the end of the file, we're still going to need a loop in here that loops to the end of the vector, or through the entire vector. But that's going to turn into a for loop. Remember, we don't need to look at an end of file anymore. It's going to be a for loop that goes to the size of the vector. So I'm going to cut that out. And notice I just cut the top of that while loop out. I'm going to stick that in here. Okay. And then here where we're doing the file in read, I'm going to cut that out and stick that in here inside my while loop. And I'm just going to go ahead and type the closing brace there instead of copying and pasting it, and just delete it here. Move those back over. And then this file close, of course, I'm going to cut that out of there. So we almost migrated the entire contents of that view names function. So just like before, this view names function, let's flesh it out here, and then we can finish our get data function so that it is getting the data and shipping it off back to this view names function. Okay, so in the view names function here, I still need this string. Well, actually, I don't need this. We'll add a feature later where we'll have a string where the user can type the file name in. So what file do you want to view the names of? Right now, we're just tackling one thing at a time. So we're just dealing with a hard-coded. We're going to stick with that hard-coded file name for now, and update that later. What we do need here at the top, though, is we need a vector. So we're going to create a vector to hold the returned vector of get data. So I'm going to create a vector string, and I'll call it vnames. And now I'm feeling a little guilty using that vnames. I should probably do that up here as well. I'm going to call this vnames as well. Change that here just to be consistent. And also, yeah, to be consistent, I should probably have lowercase function names. So I'll do save data. I'm going to change that. Sorry to get off topic here, but sometimes you just get those get off track, and you follow a thread of thought, the semiotics of thought, and you just want to resolve something there. A little neurotic that way. All right, so save data and get data. I'm going to lowercase those just to be consistent. If I'm teaching you consistency, if I'm teaching a class in C++, I should be consistent so that my programmers will be consistent. All right, so being consistent here, using v for a vector, str for a string name, lowercase function names. All right, back to the task at hand. We got this vector vnames, and then right here, I'm going to scoot down the display portion. Right here, after I declare it, I'm going to set it equal to the return type of this function, get data. Okay. Now, could I do these two in the same line? Yes. However, I want to expand on this. I'm kind of thinking ahead here. I do want to expand on this, and I want eventually the user to type the file name in. So I'm going to actually squeeze that in here, and I can't call get data until I have the file name and ship that off to get data. So that's where I'm headed in the future, which is why I made this a two-line process. Nothing wrong with making it a two-line. Yes, you could do it in one, but I'm doing that on purpose for later construction. So we've declared a vector, and then we're filling it full of the returned vector, or we're setting it equal to the returned vector from get data. And then to display the stuff in the vector, just like we cycled through the vector in our save data up here, the save data, remember, is receiving a vector and cycling through it. We're going to do the same thing. And actually, if you wanted to, you could copy this for loop. Copy and paste is a really good tool for writing programs fast. You just have to make sure that when you do copy and paste, if there's anything that needs to be changed, you make sure and change it. Like the name of this vector, it's not vdata. We have a specific name for our vector. It's vnames. And then this file out, that's not what I want in there. I want this. Okay, so that was probably a little bit quicker than typing it all. You just have to make sure you're organized in that process there. So what I did is I created this for loop inside my view names for int n 0 up to the size of, but not equal to the size of, the vector. Remember the elements in a vector, just like the elements in an array, are zero-based indices, have a zero-based index. So the 0 element is the first element. The last element is one less than the size. So that's why we're going to less than the size, not equal to. And here we have a cout that's displaying the names. And instead of string names, of course, that needs to be the vector. So it's going to be vnames at n. So I suppose if you wanted to, instead of cutting and moving that up like I did, you could just make that change here and delete what was there below. That may have been a little quicker, but at any rate, I got to where I needed to be. Cout vnames at in end line. And that really should be it. So this is the benefit of creating these functions, especially these standalone autonomous functions like we have in our data accessor. We've simplified the whole process here. In our main, look how much cleaner viewnames is, and same thing, well, add names looks pretty similar, but viewnames here is a lot simpler. We create a vector, fill it full of the return information from the function, and then just display it. And that's what you want to do with your programs. You want to separate the what we'll call the GUI, or well, it's not GUI. Sorry, it's the display portion, or the user interface. Not GUI stands for graphical user interface. Here we're programming in console, so technically it's just a user interface. So I'm separating the UI coding, the stuff that deals with printing to the screen. I'm separating it from the data layer, or the portion of your program that deals with accessing a file. And that's typical programming architecture. You have a function, or you actually have a whole separate file, portable file, that deals with accessing your database, and then you've got your functions here on the user interface side that deal with displaying to the screen. So let's go ahead and go back to our save data, or I'm sorry, get data function now. Here, get data is returning this vector. So here we need to, in get data, obviously create a vector that and then fill it full of the stuff, fill it full of the data, and then ship it back. So here I'm going to do, I'm going to create a vector here, vector string. I'll call it vdata, being generic there again. And this is again, I'm back in my data accessor header file, and I am inside the get data function. Create a vector, open the file, and then here where I'm reading a line from the file, I don't need to do that yet until I start this while loop. It can do all of that for us. So while I'm not at the end of the file, we need to put it into a string first. We can push that information into the vector. So vdata pushback. And then put into it string names. I guess technically that should just be a name. I'm going to call it name. And I need to declare that. So up here at the top, I need to create that string name, str name. Okay, so that should create this, grab the string from the file, and then we take that and put it into string name, and then we add that to the vector. We're still closing the file, and that's going to continue until the file is empty. Oops. Close the file. Maybe I comment on this loop here. I'm going to here say get data while looping through file, something like that. Okay, and then the last step here, this function returns a vector, so we need to have a return statement, return vdata. Alright, so we open the file, we cycle through the file, we loop through the file until it's at the end, and while we do that, we grab from it the line, put that into the string, add it to our vector, and then once we're all the way through the file, close the file, and then that vector we can return. Okay, so that's the end of my get data function. All right, so now let's I think we're at the point where we can run this and make sure it works. Okay, yeah, here when I made my change to vnames, I forgot to make that change here inside this vector. vnames. Okay, let's run it again. Same here inside view names, so that's vnames. I'm sure you caught those while I was programming, didn't you? Good for you. Okay, so let's cycle through both of these. Let's add another name, make sure that is still fine. I'll add a new name. I just watched Pulp Fiction, so the name Yolanda's in my head. Okay, so we should have added that name, and now let's hit view names here. Okay, so there it added Yolanda twice. And why would that be? Well, the first thing to do would be to check the actual file and see if the name got put in there twice. So that's what I'm going to do first, and this is just some debugging tactics here. Alright, so here is my text file. Open it up. So it stuck a space in there. So what is actually happening, remember with the vector, when and I mentioned this earlier, when you create a vector, I'm going to go ahead and close this. When you create a vector and use that pushback function, what it will do, if there's not enough room in the vector, it will double the size of the vector. So it's possible that there are elements in the vector that are empty strings that are getting placed into our file. So what I'm going to do to prevent that is I'm going to go into my save data function, and what we can do to prevent any elements in this vector that is getting shipped to it, to prevent any of the empty lines that may have been created, those empty elements that may have been created when the vector was expanded using that pushback function. And again, that's something you would have to know about vectors, and your textbook talks about that, the pushback function. You might want to read that portion. On page 493 in the new text, in the efficiency issues of vectors, if you read that second paragraph, it talks about what I mentioned. It says there's several different implementation schemes, but one of the common ones is to double the size of the vector. So anyway, what I want to do here is I want to create an if statement. I'm going to do if the element at that spot, if vdata at n is not equal to the empty string, as long as it's not empty, go ahead and stick it in my file. Okay? So that addition here inside of our save data function should eliminate that issue. Now, before we go back and test it and see if that did make the difference, what I need you to do is open up that text file, and then let's remove that space, and then close our file and save it. Okay, now I'm going to run this project again. Let's add another name. Add names to the file. Vincent. And then let's add a couple names just to make sure that we don't have any other issues. So I'm going to do Vincent and Jules, and type my Q. And now let's view the names. Okay, so it's still doubling the Jules there at the end. So we've got an additional issue on top of the space. Now I'm going to go to my file here and see if we eliminated that space issue, and it looks like we did. So that's good. It didn't put a space in our project. Okay. So now the question is, why is Jules getting displayed twice? There could be two possible culprits, and this is the complication of separating your stuff out into different functions. It could be happening one of two places, so you just have to check both. The question is my get data function, is it putting the name in there twice, or is it displaying the name twice here in our view names? Now, my hypothesis, I doubt this is going to be the culprit. It should just be going to the end of the file. So my guess is that it's actually putting the name in there twice in the get data function. And the way we can test to see if that's the case is we can put a little stop point in here, and we can debug our program. And I think I showed you how to do that in an earlier project. Let's do it again. It's very, very excellent tool. And in your own personal programming, when you're going to start doing this, you're going to run into these issues, which is why I wanted them to arise in our guided project here together. I wanted you to see how or how you should deal with these debugging issues where you have runtime issues. You're seeing the name twice. What do we do? Okay, so I'm going to stick that stop point in there. Okay, so up here at the top, the check box, or the little purple check mark, that's allows you to step through your program line by line. And I put a stop point there right here in this file input, or this file, or the while loop, where we're looking at the file and going to the end of the file marker. So if I hit that check mark here, it launches my program. I'm going to go ahead and go straight to the view files, or view names. I hit enter, and it will stop right there at my while loop. So let's step through this. Down here at the bottom of your options, I'm going to do next line. So I'm going to do next line, and if you let your mouse hover over that string name, down here at the bottom you can see, notice it shows you the name after it shows you the address there. In quotes, you can see John in that pop-up. See that down there in the fourth line there? John. Okay, so I'm going to keep stepping. Next one is Bon, and next one should be Jovi. So we got Jovi. So it's just stepping through my text file, reading each line. There's my name, and then Gadget, my dog, first dog, second dog, Binky. And then your name maybe. George, which we just added today. Yolanda. And then we have Vincent. Then we have Jules. Okay, so then it hasn't reached the end of the file yet. Remember, that doesn't get turned to true. I think we talked about that in the past. This doesn't get set to true until it tries to read a line and then can't, and that's when it reads, or it doesn't get any more information. Then that's when that is set to true. So here, string is Jules. If I hit next, okay, string is still Jules. So it went through, and that's when the end of file marker got turned to true. Okay, so it's actually packaging or sticking the name Jules into our vector twice. So how can we stop that? I'm going to go down here at the bottom and hit stop execution. Okay. Well, what we can do is read the first line before we enter our loop, and then do the pushback and then read. So I'm just going to do a slight reorganization here. I'm going to take this, copy it, paste it here. So now it will read the first line, and then I'm going to drag it below where we actually stick it in the vector. Okay, so now it's going to read the first line and then put it in our vector, and then try to read the next line. So then it should, this should read the line and then see if the end of file marker is hit before it loops back. Okay, so if we run this, now I'm going to debug this actually. I'm going to stick that spot back in there. Do the same thing, view names. Okay, it stopped there. step through this. So the way this thing's behaving is a little odd. It's not actually showing us these lines. It's not stepping through those lines. Okay, so when it's acting funky like that, this is another complication that comes from creating your own additional header files. What the compiler will do, it's programmed so that it doesn't do more work than it has to. It won't pre-compile a header if it's already got a compiled version of that header sitting out there. So what you actually have to do in order to get it to work through the new code that you put into your header file, you have to hit this button up here. It's called Rebuild All. So if we run that guy, it'll rebuild everything, including this header file, which it was probably just using with that last run through there. It was just using an older version of the header file without recompiling the new code that we typed into it. So now if I put my marker there and then debug, okay, it'll stop on the while loop. Now it's going into this while loop like it should. If I hover over this string name, you can see it's John, and puts that in there, gets the next name. Actually, this line hasn't been executed yet, so if I hit run there, now the next name, Bon. I'm going to run through a few of these. We're at Binky. Now, come on, you. Now George, and then Yolanda, Vincent, Jules. Okay, and then I stuck the last name in there as Johnny. So then it'll put that name in there. Now here, now that should trigger the end of file marker, and then now it will exit. Okay, and if you hit continue, it should go back to your program, and you can see that it's not repeating anymore. Okay, so the reason that was doubling up on that vector is because we were reading in, trying to read a line, and that would have triggered the end of file marker. There, we were reading it in before we were putting it into the vector in the loop. So by moving that below and then having the initial one there so we don't skip the first name, that fixes that one-off error, or by doubling that. So now if I run my program and then view, we see we don't have any duplicates. Okay. So now we have migrated to our header file everything that was in our main. And the next step, what I want to do is I want to, well, three things. I want the user to be able to type in the file name so that this thing is more dynamic. I want to add a function that will also sort the names for us alphabetically. So we're going to do those two things. So first things first, I want the user to be able to type in the name of the file. That way this program will allow the user to create multiple files. So in the add names function, what I want to do is I want to prompt the user for the name of the file before I ask them to start adding names to that file. So I'm going to create, first of all, a second string here that I'm going to call string file name. Okay. Then I'm going to prompt my user. This is again in the add names function here in the main. Prompt user for the name of the file. and I'll say cout, enter the file name with the extension. So we can create .txt files, we can create .dat file, whatever we want. We can give it any extension name we want. Now the text itself will be plain text, no matter what we give the file extension, or no matter what we extension we give the file name. So I'm going to read that in. Okay, and then it's going to start adding names to the file. So now this file name is something I want to pass to my save names function. And now I want to adjust my save names function so that it will open whatever file name I pass to it. So back to my data accessor here. Here I'm going to add that new string, and I'll call it file name. Okay, and then now here, instead of that hard-coded names.txt, we're going to pass to it this file name. Now here's the caveat. If we try to do this and run it right now, first I'm going to do that build all. Okay, it's going to give us an error right here because it's going to say that this open method has to receive a C string. So here's where that C string stuff comes into play. This particular open function, although we were hard coding what we thought was just a string, your compiler was interpreting it as what's called a C string. So this is in chapter 8, and this is how kind of this string class has evolved since C++ began. Originally, in order to have a string, it was just an array of characters. So it's a bunch of characters strung together. And then how would you know you were at the end of the array? They had an element in the array. The very last element was the null character. And you can pick that up in your reading. Make sure you peruse that C string stuff at the beginning of chapter 8. So this thing receives a C string. It has to have a C string. So we could either create a C string and have to deal with all that junk on the other side, or we can use one of the functions that is in the string class. See, this string file name here, we created it as a regular string, right? Right here, string file name, and we're passing it as a string. If you look in your textbook, there are a list of functions starting on page 483 in the old text. I'm sorry, page 472 in the old text, 471 in the old text, and then 483 in the new text. They have a list of functions there that you can use in the string class. Now, there's a function that's not listed there, which is the one that we actually need. So your textbook is just giving you a sampling of some of the functions in the string class. We need this function called C underscore string, and you can see it right there. What this function does is it converts a modern string type to one of the old C string types. So I'm going to select that there. Okay, so that little function right there is all we need, or all we should need. Now if I build this whole thing, we shouldn't have an issue. And now, when I run the program, I'm going to add names to a file. Now it asks what file name. So I'm going to create a brand new file. I'm going to call it, I'm going to call it enemies.txt. Maybe this is a list of enemies for a video game. Okay, and then add names to the file. I'm going to use some Zelda names here. Octorok, and I think that's how it's spelled, not positive. There's Dark Nut, and then maybe Ganon, and I'm going to hit Q. Okay, now view names is still viewing the names from our other project, or the other names.txt. So let's update it now. That way we can view the names that we're putting into this new file. So we're going to update both the get data function as well as our view names. So under view names, I need to prompt the user, what file do you want to see? And that's what I'm going to do right here. And remember, I told you I left this space here. So prompt user for file name, and of course I need that up here, so I'm going to do string file name. And then cout, enter the file name with extension. And we'll read that in. Then I want to pass that along to my getData function. Okay, so we're asking the user for what file they want to open, then we're going to open it with our getData function. So I'm going to change the getData function here in my header file so that it receives a string, and I'll just call it file name, string file name. Okay, so now here, the file that we're opening, we need to pass to it that string file name. Okay, and then we also need to convert it to a C string. And that's the thing about programming. It really it is a lifelong learning process. These languages, no matter what language you're programming in, unless you've been programming in that exact same language for 10 or 20 years, you're probably not going to know, or even if you have been doing it that long, you probably won't remember all of the specific functions that are necessary and the exact syntax, and that's something that you have to look up. You have to get used to in programming, being able to look stuff up, and that's what Google is good for. And I typically try to look at the Stack Overflow results once I Google something, check through those. You can usually find what you're looking for without too much trouble. And this is one of those things that I had to look up. I couldn't figure out how to convert a string to a C string, and your textbook didn't show you how to do that, so at least not in this chapter, and not where I've seen. So it was something that we had to I had to Google. How do I convert a string to a C string in C# or C++? So, all right. So now that should open that particular file. And so now let's test that out. And again, I'm going to keep doing this build all. And of course, it's giving me an error here in view names. CN statement. And that build all right there will rebuild the header file. And that's what we need. Okay, so then I'm going to run it. Okay, so now if I do view names, it asks me the name of the file. I'm going to open up that file that I just created, enemies.txt, and there's my enemies. Okay, so this program is becoming a lot more useful now. We can create multiple files, give them whatever name we want, give them whatever extension name we want, although again it's just going to be stored as plain text. Okay, so that takes care of one of the three things that I mentioned earlier. I don't think I mentioned another one of the three things. The second thing that I want this program to do is I want the user to be able to sort all of the names in the file. So what I'm going to have this function do is open up whatever file you tell it, and then I'm going to have it reorder all of the names alphabetically and then store them back into that file. So first thing I need to do is create an extra case in here. Our case 3 exits. We're going to have case 4 exit now. So I'm going to do case 4 break. And up here in my menu, I'm going to add that option. Yeah. And I'll call it sort names in file. And then this is option 4, and it's an exit. And so up here with our while loop, it's looping while the choice is not equal to 3. We need to change that to while the choice is not equal to 4. Okay, and then down here in my case 3, I'm going to call this function sort names, and I need to declare it. Here I'm trying to use it before it's been declared, so let me declare it up here, and we'll have it be a void function sort names, and I'll say this function sorts all of the names in a file alphabetically, and stores the sorted text back into the file. Something I noticed up here with my add names and view names functions, those aren't hard coded anymore, so we can say this function prompts the user and for names and stores them into, we'll say, into a file with the name the user specifies. And actually it's not just the file name, but it's also the extension. So we'll say into a file with the name and extension the user specifies. And I'm going to add that here to my view names as well. Into a file with the name and extension the user specifies. Okay, updated that. So back to the sort names. We've declared the function. Here we're calling it. Now we got to create it. We need to define the function. So down here below my view names, I'm going to do void sort names. Okay, so I'm going to declare the same things that I have up here. I need a vector and a string. Actually, I like my comment better on this one. Variable object definitions, a little more. Okay, so we have the vector names that's going to receive the data from the file. So we need to prompt the user for the file name with the extension. I'm going to copy that from up here. So into the file name with extension, and here I'm going to say to sort. Into the file name with extension to sort. Okay, so now our function, our vector vNames is going to receive the returned value of our function getData, and getData needs the file name now, so we're going to pass that string file name. Okay, so once I've received that data, I'm going to sort it. The sort function is from chapter 7. We talked a little bit about sorting, but I don't remember, or I don't recall actually sorting. Yeah, I don't believe we did that in the tic-tac-toe game. Back in chapter 7, they mentioned the sort function And then they also mention a bunch of different sorting algorithms. We're going to implement that sort function, and it's just sort, and then it receives the thing to be sorted. It can sort an array as well as a vector. So I'm going to pass to it this vnames. There's several versions of this sort function. You can pass to it a starting point and an ending point for the vector, which is what I want to do. I want to make sure it knows I want to sort the whole thing. You can partially sort a vector, which is kind of interesting. Maybe you only want to sort the top 2 or 3 names. I can't think of an example of when that would be the case, but it's possible in this. So this sort function, I'm going to pass to it sortNames.begin. Here's another function. This is a function of the vector class. The begin and end, that gives you the beginning and the ending of the function, or of the vector, I'm sorry. Now this sort function, in order to use it, there's a couple of classes that I believe we need. This has changed since the previous version of this dev compiler. The sort function now exists inside the algorithm class, and your textbook doesn't even mention that. This is where this dev compiler stuck this particular function. I think that maybe a C++. It was the C++ standard, and I looked for information on when that got moved in that C++ architecture, but I didn't come up with any answers. But it is in the algorithm class. So if I add the algorithm class now, it should compile fine. Okay, so now we've got this sort names in the file function. It's compiling, but I'm not quite done here yet. Down here in my sort names function, that's sorting the names in the file. Let's do this. Let's give the user the option to either save those names back into the file, in other words, overwrite the file, or not. So what we'll have this thing do, I want it to just display the sorted vector first, and then we'll give the user the option, do you want to save this over top or overwrite the old file. So first thing I'll do here is display that sorted vector. Okay, so a for loop, int n equals 0, n less than vnames dot size, and then n plus plus. Okay, and we will display the vector cout vnames at n, and then an inline. Okay, let's test just that portion. So I'm going to build it, build all, and run it. So sort names, enter the file name. I'm going to let's do that enemies file. GDO, that is in alphabetical order. Awesome. Okay, so that's working. We're sorting the array just fine. Just for fun, let's go ahead and test out the one of the other ones. Let's do that names.txt. All right, sorted them alphabetically as well. Great. So everything's working hunky-dory. Yeah, so now maybe they just want to see the names in alphabetical order and not actually overwrite the file, but then maybe they do want to overwrite the file. So let's ask the user if they want to do that. So I'm going to do this, cout, would you like to overwrite the file with the sorted names? And we'll say Y for yes. or N for no. Read that in, and we need to give that a variable. So up here at string, I'll do a string file name. We'll do string maybe choice, I guess. And then we'll do if, and maybe some comments here. Ask user if they want to overwrite the old file with the sorted names. Okay, if string choice is equal to, and we'll just do, we can do capital Y. I guess we can also do lowercase y, or string choice is equal to lowercase y. Then we'll call that save data function. Now here's the deal, that save data function, it always appends, it doesn't necessarily overwrite. So this is something we need to change about the save data function to make it more versatile. We can have the user save data in append mode, or if they want to, we can have the user save data in overwrite mode. So here's how this is going to go down. I'm going to do save data, call the function, pass to it vnames, and then also the file name, string file name, and then I'm going to pass to it a Boolean variable that's true or false. I'll have that variable say append mode is append mode. So is append mode true means yes, I want it to append. Is append mode false would mean no, I don't want to append, I want to overwrite. Okay, so I've added a new parameter here to the save data function. Now I need to add that in here. So this save data function, add a new parameter, bool is append, or is append mode. How about that? Okay, so now in my function, in my save data function here, I need to have a statement here in specified mode, and I'm going to say if is append mode. And remember, with Boolean functions, you don't have to say if that is equal to true. It's already a true false variable, so you can just say if is append mode. If that is true, then we'll do this, file open append mode, and then we'll do else file out. Oops. Actually, you know what? I'm just going to copy this, paste it, and then just delete this append portion. That opens the file in overwrite mode. Okay, so now we've made our data accessor even more versatile, asking the user, hey, do you want to open this in append mode, or do you want to overwrite when you save to that file location? So I'm going to build all again. Okay, so now back up here in our add names function, here our save data function doesn't have that. Now, it's something you can do, and I'm doing this just out of interest of time. If you wanted to, you could create another save data function that has just those two parameters and have an overloaded version of that save data function that receives that Boolean variable. But I'm going to, yeah, you can do that if you wanted to. I'm just saving time here and just going to have one single save data function. So that means here I need to do true. For this append mode, we're adding names to the file, so we want to be in append mode true. Okay, so now build this, and from now on, now that I have that header file, I'm going to hit that build all or rebuild all before I compile and run. Okay, so let's take a look at our sort names 3. Enter the file name. Let's go back to that enemies file. There they are sorted. Would you like to overwrite the file with sorted names, Y for yes or N for no? I'm going to do yes. Okay, So now if I view the names in that enemy file, enemies.txt, they should be sorted, and they are. And now let's do the opposite of that. I'm going to do sort names, and I'm going to do that for my names.txt file. There they are sorted. Would you like to overwrite the file? I'm going to add an end line in here, by the way, and then I'll probably another end line right after this. So move that to the next line. Here I'm going to say no. Okay, so now if I view the names in that names.txt file, they should be unsorted, and they are unsorted. Okay, so now the user has the option to view the sorted names and overwrite the file, or just view them sorted if they want. Okay, so here I'm going to put an inline. I'm going to do cout inline, putting that before my would you like to overwrite the file names. Actually, I don't want that semicolon in there. Let me do a new line there. Y for S, N for no. Okay. And if we wanted to, we could test that out. Let's build all and compile. So let's do the sort names again. And actually, enemies is already sorted. So let's do the names.txt. There they are, sorted. Would you like to overwrite the file with the sorted names? And I'll say no again. Okay. All right, the very last thing, and I know this project has gotten long in the tooth, but this is how things are going here for the middle of the semester. We're getting to the bulk of our understanding of C++, or we're getting to the bulk of the course content. So these are going to be a little bit longer. So this is getting a little bit longer, but just bear with me a few. Of course, you can always pause this and pick up where you left off later. But the last thing I want to add is right now we can only add names, a single name. We can't add a name, first name and last name with a space. So this is the last thing, and a very important thing that I want us to pick up here from chapter 8, and that is being able to pull from user input an entire line, including spaces. Now this can be done with a special function that is mentioned here in chapter 8. It's called the getLine function. So this getLine function appears on page 465 in the new text, and then it appears on page 454 of the old text. And what this getLine function does is it allows you to read a whole line, spaces included. So you can have an entire string with spaces. So this little operator here, that will only read to the first space. And actually, it won't even read the enter character. So it will read up to the enter character, or the space character, whichever it hits first. So that's the drawback of this extraction operator. So we're going to go through this entire project and change that extraction operator. Okay, so here in the add names function, where we are reading in just to that using that extraction operator enter into the string name, I'm going to change that line, and I'm going to use the getLine function. So now we're going to do getLine, and the two parameters that the getLine function receives is where do you want to get the line from. So we are still getting it from CN, and then we're reading it into string file name. But what this function will do is it will allow you to type spaces in there as well. So reading that getLine in there, and then here where it says enter another name, that needs to also be a getLine function. So here I'm going to change this to getLine. Okay, so let's run this right at this point. We're going to see some issues, and your book talks about those issues. So let's take a look. I'm going to do the build all first here, and then run it. And so let's create a brand new file. That way we can see what's happening. So I'm going to do add names to a file. I'm going to create a brand new file. Let's call it maybe getline.txt. Okay, so notice what just happened there. It says enter a name to add to the file, and then it went ahead and skipped ahead to the enter another name. So what's going on there? Well, in your textbook, you should, if you read the getLine portion, you'll notice it talks about it cautions you in using getLine in your same project with also the extraction operator. And here's why. What's happening is this CN extraction right here, this will read up to the when you hit enter, but it leaves that enter character, that invisible enter character, it leaves it just sitting out there in the CN, and then this getLine will actually absorb it. So this getLine reads to that enter, and it will absorb it. So it's absorbing that enter as like as if the user just hit enter without typing anything. So this needs to be adjusted. This needs to be a getLine. That way this original getLine absorbs that enter. So one of those idiosyncrasies to C++, using that extraction operator, will leave that enter hovering out there, whereas this getLine absorbs it. Okay, so now if I build all and run, so now I'm going to run this add names again and enter a file name. Okay, so now look what's happening. It's absorbing the enter, this getLine that we created here. It's absorbing another enter. It's absorbing the enter that's all the way back up here in the read-in choice. Okay, so what we need to do here, now this herein lies the issue. That CN, or that choice, is an integer. If we tried to convert this, I'm going to comment this out for a moment. Oops. Let's undo that. I want to comment this line out. If I go in here and then do getLine and try to read into it, notice here it says char type underscore s. There's actually, this is an overloaded function. Basic iStream. I'm looking at the first elements that it reads in here. They're all strings or characters. So if I try to do this, getLine in choice, or I'm sorry, CN is where I'm getting it, and then in choice, try to read it over to in choice. That's a drawback of the getLine function. It won't read integers. It only reads string, or it won't place what you read in. It won't place it into an integer. Okay, so how do we solve this issue then? Well, luckily there is a function out there that's called getChar or getCharacter. So I'm going to do this getChar function right here, and what that is going to do is that's going to absorb the carriage return that this thing is, that CN extractor is just leaving hovering out there. So a really odd thing, and this is again another reason C++ is a more difficult language than some of the other languages. The more modern languages, Java, C#, they take care of all that for you. They don't have that C string issue. So we need that getChar there to absorb that enter. That way this getLine won't be absorbing it. It will allow us to type in a file name. So I'm going to rebuild again and run it. Now if I run add lines, enter the file name with extension. Okay, now I can do it. So I'm going to do getline.txt, enter a name to add to the file, Steve Zissou. Enter another name. So now I can type spaces into my names. Let's do Kingsley Zissou, if you've seen Life Aquatic, funny movie. And let's put another name in there, maybe the director of Life Aquatic, Wes Anderson. I'm a pretty big fan of most of his movies. Quit. Okay, so now we're having an issue with quit. One last thing I did want to mention, because we have these include files here in our header file, we actually don't have to have these in our main because they are getting included here. Now there's nothing wrong with leaving them there. Actually, this file stream we don't need at all, since our main isn't dealing with our file input and output anymore. So I am going to delete that one. Now technically we wouldn't need these because they are already being included here, but there's nothing wrong with it. It'll just include that header file twice, and since this is a portable header file, you know, I'm putting these in here, and we can export that, or we could use that header file in other projects, and you may not necessarily look or know or have to coordinate between your header file and your main file what include statements you're using. But I did want to mention that since they're being included here, that they actually don't, some of them, the ones that we have included in that header file, don't have to be included twice, but it doesn't hurt anything. So happy programming, and good luck with this project. And your homework, you should notice, is I want you to do one of the projects from the end of chapter 8, one of the programming projects. There are 16 of them in the old textbook, and in the new textbook, you remember how they were kind of reorganized. In the new textbook, there are 17 programming projects, and there are also 7 practice problems. So I want you to stick to the programming projects. Do one of those 16 or 17 programming projects at the end of the chapter. So implement some of the stuff we've learned here in chapter 8, and if any of those projects ask you to save data to a file, such as number 13. Number 13 is a really good project dealing with XML. That I recommend that one. It is going to be a little bit harder and longer, but it will benefit you more than some of the other projects. And then number 16 as well, and there's a few others in there that ask you to save data to a file. Well, guess what? You've already got a header file right here that you can use. So you can add this header file to your project. And the way you would do that, you could copy and paste, I suppose, but you should be able to add to project, and then it'll ask you you can open a file and you can grab that header file directly from, you'd have to navigate to it, but you can add it and use it. So this data accessor is this standalone nice thing, and so hopefully you can see the advantage of it, although it took us a little bit of time to migrate that stuff out of our add names and view names. Well worth it, because now we have this portable file that you can use for other projects. So again, happy programming and know yourself.